Hello, and welcome to another exciting edition of SDL and OpenGL. My name is Nate Nessler, and this is for Hyperactive Studios. Okay, so now before we left off with the code blocks with SDL, and so now we got our everything installed. We got our SDL set up. If you don't have that, please check out the previous video so that you can get that set up. And then now we need to look at actually getting an OpenGL SDL project working within our setup here. Okay, so let's have a look at that. I have a few things in here that we might make use of later, but not necessarily right at this moment. Alright, so first off, I am coding this up to be cross-platform compatible. I'm trying to go off of memory from before for doing the Linux setup, and then I can devil test it later. But this might change as we add more, well not might, it will change as we add more and more things into here. Some stuff has to be particular to Windows, other things particular to some other platform, whatever, and then we can denote that with if def here. So if defined Win32. We can also add Win64 to this too, FYI. So that's also a possibility. For those who are wanting to do 32-bit and 64-bit compatibility, and I might add that later because that's important to me also. And yeah, so before we try to compile this, because right now if I try to compile this, I fully expect it to not work. If I'm doing this application right here, I fully expect it to fail on trying to build it. Yeah, look, I just got a tremendous number of errors in red down here at the bottom here, which is great, and it's all telling me that basically it doesn't recognize OpenGL, and I understand that. So first off, how do we take care of that? How do we get rid of that problem? No problem. First we need to select our project underneath the workspace. We're going to right click on it, and then we're going to go to build options. So after I select build options here, I'm going to go over to my linker settings here. Okay, so once not at compile settings, but linker settings. Okay, cool. You may even want to have inhibit warning messages with W here for wall, or actually all computer. I like wall in particular. All computer warnings overrides. You might want that for your debug. That's really a nice setting. It gives you more information. That one's a particular nice one to have turned on. Anyways, over here to linker settings, that's not going to make your OpenGL or SDL work, but that just gives you better warning messages. I'm going to click add here, okay? I'm going to type in capital GLU, then 32 right here. And this is for OpenGL, okay? And then I'm going to say add open with a capital O, lowercase PEN, and then capital GL, and then 32, like that. Okay, say OK to that. Now we need to add the ones for SDL too. So I'm going to say SDL, like that, all caps, and then one more, and that'll be SDL with lowercase main. SDL, and then lowercase main, like that. Okay, and that's added. Now, we would have to go in and do that for release also in an overall project. That's going to take some time. We don't want to do that. So let's do it the fast, easy way. So I'm going to select this one, and I'm going to hold down Shift and select all the way to the last one, like that. And I'm going to say copy selected to. And I'm going to copy it to our entire project, say OK, and then I'm going to click it again, and I'm going to tell it to go to the release. So now I don't have to worry about retyping in the same configuration for the release. Now I'm over here in the release, check it out. I got the same configuration across all of them. Awesome. That makes life so much easier. It's not even funny. Okay, going further. I need to go into my search directories now, under my debug, and then we'll just again, copy it over to the other one. I'm going to click add here for my compiler, and it needs to know where some stuff is. So, for instance, I could tell it where my SDL is, and that'll be useful. Depending on how you want to do your setup here, I could simply just come in here where the SDL is and say include, and I could say right here, like that. Keep path relative, sure. Go ahead and select that one because I have my project on my E drive. So hey, it's up to you how you want to do yours. I went ahead and copy and pasted that. So what it is, I did a Control C when that thing was highlighted, and then all I have to do now is say Control V, and it pastes in, and this takes me back to where I was. And the cool part about it, I can now select SDL if need be, so I can have my thing set up either way I like. It doesn't matter. I still get to these files either way. And I can do the same setup again here and just hit V again. Control V, I mean, not just V, but Control V. And then I can also select, well, lib if I needed to. I really don't need to select lib, but if I want to, I could select lib here, like that. And then that's going to give me my SDL for my include and for my lib. Now I need to do something similar for OpenGL. And in this case, OpenGL is going to be stored back over here in my MingW setup for the Linux here. So in my case, it's under Program Files x86. So I'm on a 64-bit system, so I can have 32-bit and 64-bit. And since code blocks here is 32-bit, this is where it's going to be. So MingW, and then I'm going to go down to, or MinGW, however you want to say it. It doesn't matter. It's the same stuff. And then include here. And then I can just say include like this. Keep path relative, and I could say OK. And you're like, well, I didn't get a chance to copy that. That's no problem. I just went here and clicked edit, came back to here, hit Control C to copy that. And now when I click add, I can just hit Control V to paste that in again. And if I want, I could dive in further inside my include and choose GL, for instance. Say yes, and then say OK. Awesomeness. Now this is cool because I can just copy all this over. So into my main one, here copy all to my SDL, select the next one, copy all to the main one, so on and so forth, all the way down the line. And this just makes life easier. I'm going to choose release now, so that release has them all too. And I'm just going to keep doing this for each one, selecting release each time. And this now sets this up to where it can find these libraries when it goes to compile. Otherwise, it won't be able to find them. So that's important. Let's hit linker now. And I'm lazy, so I'm going to hit paste like so, and bang, there it is from before. Add, Control V to paste again over here. Expand my include. Choose GL. Ta-da! Just like that. Oh yes, it's awesome. It's lazy. It's great. We'll go over here to compiler. I'm lazy again. So sorry, but I am. So I'm just going to copy that again. And then come back over here to my linker. And then Control V to paste. Add again, Control V to paste it in. Come back over here to my include. Choose SDL. Say yes. OK. There it is. Add again, Control V to paste. I'm lazy. Choose lib now. Say OK. Yes. OK. And now they are. There they are. Alright, and we're going to do this to our main category with copy to. Over and over again. Again, just copy to our main project overall. Alright, and then now I need to do it back again, but this time for release. Okay. And that's it. Now later on when we add more stuff, we'll have to add additional libraries to our compiler and linker, and also additional attributes to our linker settings and things of this nature. Over here, we'll have to add additional libraries here also, especially like when you're doing CG or OpenCL or something like that. You'd have to add them there. But this is all we're messing with right now. It's just some OpenGL with SDL, and then once we start adding other things like more advanced OpenGL like 3.0 or 2.0 stuff, or OpenGL 4.0, 4.1, etc. You have to add additional libraries yet, even more so into these, and also link them in until where they are. Now, in the case of the OpenGL, they're just going to be in the exact same place with the rest of the OpenGL, so no big deal. You don't have to tell it anything more on the search directories. But under link libraries, you'll have to add additional entries in here so it knows to compile for those. And not just, so that way it knows to ignore other libraries it doesn't need. Alright, say OK to that, and then say build and run, and bang, it will work at that point in time, just proving that it works. Now nothing's going to appear for you because you don't have any code yet. So we need to do we need to code this file out here. And the cool thing in this nice wonderful program is that it will definitely allow me to zoom in, which is excellent. If only I could remember. But I know it does. It absolutely does allow zooming. I thought it was under View, Edit. No, it's not. It's under Special Commands. Yeah. Okay, so if you need to zoom in on your editor here, it's under Special Commands here, and then Zoom, and you can say In. And boy, I wish I knew a hotkey for that, but I don't. So I'm just going to do this several times here. Special Commands, Zoom In, like that. Okay. So hopefully that makes the font rather large and easy to read on the screen here. And I prefer that over other methods. Okay, so here we are. We need a #include and then in quotes. Now you can either do it either way. I don't care. If you want to do slash here with it and then have the SDL folder like that, bang, that'll work fine. If you want to do it, well, for Windows it'd be more like that, but it seems to ignore the fact that you do it that way, and Windows tends to take it anyway, so whatever. And this will make it Linux compliant. Otherwise, if you don't do the slash this way, it will not be compatible with Linux. Just an FYI there, just because I've been coding on both systems, I noticed that you can actually do your slash the wrong way on Windows and it'll work. If you do the slash the wrong way on Linux, it will not work. So if you're going to do the slash, you need to do the Linux method like this versus the Windows method like that. Okay, or you could just sit there and link it directly with SDL, where we pulled out our SDL files directly in the folder, so it's just sitting there in the include, and it'll find it directly, so we don't have to worry about it then. If def space win32 here, and this is for Windows 32, and we could add this for 64 too, but #define space win32 underscore lean underscore and underscore mean, all caps. What this does, basically what this does is removes all the junk from Windows and gets down to just the absolute minimum core that we need in order to have this application run on Windows. You might be going, well, we're using all these external libraries, we're not even using Windows libraries. Even so, you still have to have a minimum of Windows libraries in order to actually have the application run and work. This reduces the overhead. Since we're using so little of Windows, we want to use the least amount possible. And by defining this attribute ahead of time, this lets us use the minimum that's required. Then after that, you need to say #include windows.h. You must include windows.h, or otherwise it will not work on Windows. Open greater than sign, close, well, open, close, less than, greater than signs anyways. And then # and if. And this is only for Win32. Here. Now, Win64, if we were doing a 64-bit Windows application, we could also include that and do its setup. Okay, so after that, we need to look at how to include OpenGL. And our setup is going to be different according to which target platform we're aiming for. So, on the Mac, it's #if space defined open parentheses underscore underscore apple underscore underscore open close parentheses, sorry, space and space defined open parentheses underscore underscore mock here, all caps, underscore underscore close parentheses, and then we're going to do #include open open close greater than less than signs OpenGL with a capital O capital GL slash GL lowercase here .h, and you'll notice that the slashes are identical to Linux. That's because the Mac is running on Unix, and Unix and Linux are like 99% the same thing for the most part. So when we go from a Mac to a Linux, it's not massive headaches to make the transition between the two. The biggest transition is going from Windows to Linux, and we're handling that now right here. So cool, not going to be a problem for us with this setup. #include here space greater than and less than signs here, OpenGL slash with a capital O, capital GL here, GLU.h. Alright, so we need both of these OpenGL libraries here. And this is just for basic OpenGL, OpenGL 1.2, 1.3, is your maximum. And that's could be the most basic OpenGL that comes with Windows. Anything above and beyond that for OpenGL, Windows does not include with it. So be aware of that, and you'll have to include the additional libraries. You can expect them to absolutely not be there. # elif space here in parentheses Linux, all lowercase, close parentheses. I found that only lowercase worked. I know I've seen people write that you can do it in all caps. I haven't had any luck getting it to work in all caps. I've only got it to work in all lowercase. So it needs to be written just like this. I'll double check it here in a bit, but that should be correct. Also, # include, and this is different. And caps and capitalization matters, case sensitive for all this stuff for Linux and Mac, because it's Linux and Unix, and there's no you cannot make a mistake of doing capitalization or not doing capitalization. You can only get away with that on Windows. You have to be precise on Linux. So if you're used to not having to be precise on that, you have to get in the habit of being precise on Linux and Unix. So be aware of that. And Mac is Unix, so when I say Unix, I'm also including Mac. Alright, so # include here, open close greater than less than signs, capital GL / lowercase gl.h here. So you'll notice this is identical to the same setup, and that's the case for Linux and Unix here. But on Linux it is a capital GL for the folder versus a small gl for whatever reason. That's the way they always name it. # include here, open close less than greater than signs, capital GL here / GLU all lowercase .h. Alright, so # else, and then we're going to do # include greater than less than signs here, GL, and this is for Windows, it's a lowercase gl. And you can do a / here. We could do the Windows / if you like, it doesn't matter. You can define Windows here, but at this point we pretty much covered everything else. You could, I guess, support different Unixes if you like. It'd be the same as Linux here, should be anyways. GL.h here is capital GL for the file name versus lowercase gl. Of course, you can mix this up and it'll work fine on Windows, but I don't know, just trying to be a little precise here. # include open close greater than less than signs GL / GLU.h here. And then we're going to end it all with a # and if. And that lets us close it out. Oh, before we got into that, we also needed to find # if def space _ C++, all spelled out, and then # include open close greater than less than signs C std lib close. And the reason why we're doing that is so that we don't have to use using namespace std, and we don't have to do that because we have that C in front of it. So this lets us do a standard lib as without having to type that out. And of course, using namespace std is not compatible with C, only C++. So having that in there allows us to switch between C and C++ easily. You don't have to do this, but it's just makes it a little more flexible. I think we're going to kind of go away from this later, where we're just straight up doing C++ / C all in one app, because I do a combination of the two, and I don't do just straight up C. So I intermix the two. # else instead of a lot of other programmers. That's standard for game development, period. # else here, and then so basically for doing C, basically # include open close greater than less than signs std lib.h, and that makes it compatible for C. And then # and if. So that way it's going to run no matter which one you're on. Alright, so that gets us started and set up here for just getting our application in the ballpark. Alright, so let's talk about some naming conventions and some different ways of doing stuff and where some of this stuff comes from as we go through this code here. So let me go ahead and save that real fast. Alrighty. Now const here for constant, and this makes things run faster and also makes it where someone can't change the size of it after the fact. For the window height and width. Now we could actually set this up to where it's not constant and then allow for window resizing. We'll get into that later on. So how to actually make your window be resizable, and then people can change it on the fly during runtime, which is cool if you want to do that. right now we're just doing this as a constant. So const GL size I, and this is OpenGL, and this is integer based OpenGL, and this is special data type in OpenGL. So OpenGL has its own data types, and so does SDL. And the reason why is portability. You have these different systems, and you define an int. Well, what's an int on a 64-bit system versus a 32-bit system? They're two totally different things. So in order to gain standardization across all different architectures and platforms and things of this nature, what they did is they find their own data types, and not to mention with all different types of programming languages too, just to add complications to the problem. We have these predefined data types here for OpenGL and SDL, and I'll tell you which one is from which. And basically, this makes life a lot easier for defining it. Okay, so real quick here, so that's what's going on here. So window width here, and I'm going to set it to be 1,000 pixels across, equals 1,000 semicolon. And you can make yours whatever size you want. I don't really care. You can resize it, no problem, just by changing the number here. Const GL size I here, window width, equals 950 semicolon, so 950 pixels for the height. And it's totally up to you what you want to do. So here, if you're at 1024 by 768, this is going to be too big for you, and you will need to downsize it. Standard game film development is done at 1280 by 1024 or higher, sometimes 1600 by 1200, etc., etc., some of these resolutions. So that's kind of standard for the development. So I'm going to have my resolution at 1280 by 1024 because it's standard for the industry. Also note that doing this development and such, that the higher the resolution you make it, the lower your performance is going to become on the system, because that much more it has to draw for pixels for doing a pixel draw or anything of that nature. So the higher the resolution, the more it's going to hurt your performance too. Okay, so bool here, space left, and then uppercase M, and then lowercase mouse. And the reason why I'm doing this is not part of a class. If it's class-based variable here in C++, then I make it the first letter uppercase. So this is how I tell objects from just standard variables. And this is also standard as a programming method for how to code. And basically, you just make the first letter there lowercase always. And then I do camel casing thereafter. And if I need to, if it gets confusing, I use an underscore, but otherwise I don't. So this keeps life easy and simple. In this case, I have a mouse button. I get into doing the mouse programming here and shortly after. I think in this first one here, do we have mouse in here? We do have mouse in here. Okay, so yeah, mouse matters on this one. Okay. Good to know. I didn't go ahead and implement zoom, but we could do that easily, which is very cool. And you can just do that with another mouse click if you like maybe right mouse. When you move the mouse while holding down right mouse, depending on the value, it zooms in and out on your object, which is cool. You could easily do that. But and I might just throw that in there later on in the video. We'll see. But yeah, we're going to be implementing the keyboard and the mouse with SDL right out of the box, and this is really easy to do, and it's really awesome. Documentation I found to be pretty hard to come by for SDL, and having a real clear way of coding something is difficult to find, but including books. So this might end up being extremely useful to people trying to learn SDL for things other than OpenGL too, for that matter. But left mouse here, button pressed, and this equals false semicolon, and we're just doing the camel casing. So camel casing meaning that every beginning of each word is an uppercase letter. Bool for Boolean, and this is going to work out fine for us. Just copy and paste this. Don't waste time. Copy and paste this twice here. Change left to middle. Change left to right for this one here. And you're done. That makes life easy. So now we have middle mouse button press, and then we have right mouse button press too. Const space float space rotate X, capital X here, and then speed. I didn't put another capital S here for the camel casing because it got confusing. having two capital letters together like that. So that kind of would suck. So I found the good value for this is actually just going to be starting out with equals 0.5f. Now the f stands for floating point, and this makes it compatible with OpenGL. OpenGL wants you to actually label your numbers as floating point or integer or something of that nature, so it knows what you're passing it. In the case of a floating point number, you always need to put f there for compatibility. So const float, and again you can just copy and paste this over again and change the x to a y here, and now you'll have rotate y speed here. So again, the copy and paste, the select it right here, Control C, and then click on the next line, Control V as in Victor to paste it in. Then const, do the same thing again, paste it yet one more time, and change the rotate x speed here to zoom speed with a capital S for speed here, and then make it equal to 0.1f semicolon. And I'll make that go a little faster. Okay, let's go on further now. And this is going to be used in order to rotate our cube. So let me just explain that real quick. So here's our little application, and later on we'll add a caption up here, but I don't want to do it yet. And if I use my arrow keys, I can move my wonderful cube around with my arrow keys and on my keyboard. And I can also have my mouse and I can click and grab and pull it and move it as I see fit. And I can do it pretty fast, assuming the video can keep up with that. I've also set it up to where if I hit the escape key, it closes it, or I can click on the X for the window to close it. So that's basically what we're doing here. So that's what the rotate speed is. That deals with the speed of the rotation of the cube. And the zoom speed allows for setting up our zoom speed for zooming in and out on the cube, which I might implement here in a bit. GL float here, and this gets into again OpenGL data type here. In this case, it's float. For doing decimals, floating point precision. So we're going to do rotate here, capital X equals 45.0f. Now, and the reason why we're doing this, okay, so when this launches, we're doing 45-degree angle across the x-axis and the y-axis. And the reason we're doing this is so that it starts out with a really cool angle when we're seeing it. And it lets us know, hey, it's 3D right away. Otherwise, it would look like that. And good luck telling that's 3D. It just looks like 2D. If it's totally spot on and not at a 45-degree angle, when it first comes up, it's just going to look like a good old 2D single-colored square that looks like nothing until someone grabs and moves it. So it's going to look really boring. So we want to start it off making it look cool. So we're going to do it at a 45-degree angle to make it look cool for a starting point. Okay, so GL float here, and just copy and paste this again. So we're going to do, Control C to copy, Control V to paste right here at this line, and then we're going to say GL float space rotate Y with a capital Y equals 45.0 F semicolon, and this is going to put it at a 45-degree angle on top. So just explain this real quick. X is going to make it go from this direction to like that right there. So it's going to be rotating 45 degrees along the X, and then rotating 45 degrees along the Y. It's going to make it drop down like that. Okay, so that's what we're doing here. Okay, cool. All right. And then you can copy and paste it again if you like. GL float here, for change that rotate X to zoom equals negative 5.0f semicolon. Okay, now let's explain this here real quick. Now the problem with our setup here, this is kind of strange, but actually what happens is that there's not a real camera in OpenGL. So this is a little tricky to explain. Instead of moving the camera, you literally move the entire world, if you will. And you get the same effect, though. So it really doesn't matter. But instead of like the camera moving through the entire environment moves through the camera. But since everything's moving exactly the same, you can't tell. It looks like the camera is moving through the environment instead. So it's kind of like a trick, if you will. There's really no actual camera defined. And so we're just looking through the eye point of the scene, which is the central location, and we're literally moving the entire world through that central location in OpenGL. And that's essentially how it works. And that's why we had to move the cube -5 units back, because in doing so, it makes the object come back from the point of rendering for the scene, which is our model view perspective distortion matrix, and pushes it back 5 units from where we're looking at in the scene to where we can see it. Now if I'd done 5 positive units, it would put it behind the camera, if you will, or behind where we're looking, and we'd never even seen the cube. So we need to put it 5 units back from us to push it back from the camera. Now that's important. The other thing about this is that this is what's called a state machine. So once I say translate -5 units and I don't update it, everything's going to get pushed back -5 units. So that works. So by setting that up, I can literally translate the entire environment, or in a sense, basically act like as if I'm moving a camera through the scene by literally moving the entire scene, due to the fact that we have a state machine set up in OpenGL. So basically once we set something, it's always doing that up until it's told to change. So it makes everything move back -5 units. This makes life easy, because now when we create a cube and then create some other things in the scene, everything gets moved back -5 units automatically, basically. So this makes life easier. By default, if we did not move back -5 units, we would have literally been inside of the cube instead of having the cube seeing it from a distance here. And I can prove that to you real quick here, actually. So I don't have to say, it's this, it's that, blah blah blah. Let's just prove it real quick. Alright, so here we are. We're inside the cube, as you can see. And that's why we need to move it back -5 units. Also, I'll show you what happens if we made that just 5 units, for instance. Where's the cube? The cube's behind us now. So, that's not what we want. So -5 units here. Kind of make the, make it hit home. Is going to allow you to have the cube in front of the camera, more or less, if you will. Well, there's not really a camera, but you get the idea. So that way we can see it easily. Okay, let's get to the next part here. Unsigned int 8. Now this is an SDL standard default data type for SDL, and basically what this allows is for it to be basically a 8-bit integer, unsigned. So it's 1 byte in size, if you will. They have 16-bit and a higher, different ones for SDL. In this case, we want our key state for our keyboard as a pointer, so that way we can load in a whole bunch of the keys to point to a data array of keys that have been pressed. And that's what we need to do. And we're going to start it out with null, so it has nothing in there. And that's capital N-U-L-L. It has to be all caps. Cannot be lowercase. It is case sensitive for that. And then semicolon is what it's equal to. And I don't know, I just did key state and I did key mod on another one later. Oh, we'll not get into that later. Alright. So that kind of lays out what we have going on here. Now we need to create our view, or our window, if you will. And basically we're passing in our width and height of the window when we pass in our window width and height into this function here. And we're going to establish the projection matrix, okay? Or it's a fancy way of saying we're going to render our graphics, or display our graphics, if you want to look at it that way, as perspective distortion. Or think of it like a camera lens, where you have distortion from the lens based on how close something is or away from the lens. That gets into that perspective distortion. And that covers how this whole thing works here. Okay, so we're going to do open curly brace here, and then we're going to say GL viewport open parentheses 0, 0, width, height, close parentheses, semicolon. And I'm like, whoa, where'd that come from? 0, 0 is going to be your top left corner here, and then your width and height is going to define the bottom corner. And with those two values in there, it can figure out the dimensions of the screen, if you will. And in this case, it doesn't have to necessarily be up the corner of the screen up here, but it can be just a window that's created. for its dimensions, if you will. So this way, the viewport will fit the actual window itself for its dimensions, and that's what we want. And so that's why we're passing in the window width and height, so that it becomes the exact same size and fits the window perfectly for the viewport, for being rendered in the 3D graphics to be displayed in our window. Okay, so now we have our GL matrix mode here. So open parentheses, GL underscore projection, close parentheses, semicolon. And what this is our camera perspective distortion I was just talking about a second ago. And this lets us do that distortion. So we need to have our matrix mode set to that, so when it multiplies this matrix mode, if you look at the explanations for how to go about this in the other videos, for theory videos, for the series here, you need to check that out. It explains how the GL projection system works, and this basically creates a matrix that is going to be multiplied times the points and vertices of a model to distort it and make it display properly. GL load identity, open close parentheses, semicolon. So this loads the identity matrix and wipes out whatever has been previously done. So that way we have no distortions, we have a clean slate. Basically, think of it like a blank piece of paper before we start drawing on it. We want to have everything clean slate there. So that way any motions, movements, transforms, whatever, it gets wiped out for the very next frame that's getting rendered, and we don't end up incurring automatic animation or anything of this nature. Because, you know, think about it, it is a what do you say? It is a state machine. So if I go ahead and run this, basically what would happen is, say I moved this like that, right? Or we rotate it 45 degrees by 45 degrees. Every frame, it would keep rotating at 45 degrees by 45 degrees automatically if we did not load the identity matrix and multiply this through. If you look at some of the previous training videos for the theory on how to wipe that out, then you would understand how loading the identity matrix is literally going to multiply all these zeros through and wipe out any other junk in there. Well, I mean, not multiply it, but it replaces everything but the actual scalar. And the scalar on identity matrix is just going to be 1, 1, 1, so it's going to be the original size of the model before anything actually happens to it. So basically a clean slate. Essentially, that's what's going on. Okay. And I could load that up and show you mathematically, but yeah. That was previously explained, so go back to other videos to see the explanation, please. I don't want to go through. Well, okay, I will. I'll do it. Wasn't planning on doing it, but I'll do it just for completeness and make life easier for everyone in question here. So I just need to pull up maxima. Would probably be ideal here. Math here. Maxima. Yeah, I think this one is the one I need to launch. Close. Okay. And probably matrices here. Yeah. So here you see our identity matrix here, right? All ones all the way down the line. And if you remember right, this is our scalar here for scaling our model. So scaling along X, scaling along Y, and scaling along Z. And then everything else is zeros here. So if you remember right, your transforms, we going down here, and I very well may have that in this thing. That would not shock me if I did. Huh. Okay, yeah, so here we go. Transform X, transform Y, transform Z right here. This number here is Z, Y, and X for your transform. Versus scaling here, and this is a non-uniform scale of X, Y, and Z. And so when we replace this with straight ones, check it out, we no longer have the scaling here happening on X, Y, and Z. We also lose any transforms. We're translating it, moving it, gets wiped out, and then rotations get changed too. Check it out, all the rotations are wiped out. Rotate X, rotate Y, and of course rotate Z. And this is Euler type rotations. We'll get into quaternions at some point in time. They're way more complex, but that's an Euler rotation. We do have to worry about gimbal lock with Euler rotations, but for now it's simple compared to quaternions. Alright, so GLU perspective here, open parentheses 45.0f, comma, open parentheses GL float, close parentheses width slash divided by open parentheses GL float, close parentheses height, comma, 0.1f, comma, 200.0f, close parentheses semicolon. And this basically sets up our perspective distortion. 45-degree lens is basically what we're doing here. We're saying GL float for our window width divided by the GL float of our window height. And then this right here is our clipping plane. So how close our near clipping plane. So okay, so essentially how does this work? Well, I don't want to render, I can't render into infinity. Otherwise my calculations would never end for trying to solve some kind of calculation. So we have to have a begin and end to the space in which we're going to render onto the screen. So by having it at 0.1, we're saying anything closer than 0.1 to the camera does not get rendered and gets cut off. Anything further out beyond 200 units just gets cut off and doesn't get rendered. So that's basically how we can set up a defined space here for rendering out. And then we have a 45-degree angle for our lens, and so that ends up creating a trapezoid, if you will, that cuts off at a certain point. If you want, I could draw it out real quick here in GIMP and show you what I mean. Well, actually I've explained this very well in previous videos for the theory, where I showed how in Blender in 3D how that actually works much better than I could actually explain it in 2D starting to think about it. Yeah, that's a really good point. But that basically sets up our bounds for defining our distance which something can be rendered. We're going to close this off with a curly brace, and then we're going to do another void here. We're going to do init GL, and this is to initialize our OpenGL. Open parentheses GL size I space width here, comma, GL size I space height here, close parentheses, and then open curly brace. So establish projection and then matrix here, open curly brace, width, comma, height, close parentheses, semicolon. And then we're going to do a GL shade model here, lowercase gl, uppercase S and M for camel casing, open parentheses, GL underscore smooth, close parentheses. And this is going to give us a really smooth, gives us higher quality results, if you will, and gives us a better display setup. There are different setups, but smooth is going to give us the best look. So that's why we're going to go with smooth. Then we're going to do GL clear, capital C here, and then color, capital C, and then open parentheses 0.0f, comma 0.0f, comma 0.0f, and then here we're going to say comma 1.0f, close parentheses, semicolon. Okay, so what is this saying? We're saying clear color. So every time the screen updates, all right, we're going to have basically a color get loaded in. And the reason why we need this, all right, so say when I grab and move this, see how it's black everywhere else? 0, 0, 0. So RGB. Red is 0, means it's going to be black on red, no red. No green, no blue, right? Because it's 0 for G for green and 0 for blue, B. So with 0, 0, 0 there, it's going to make it black, all right? So this is great, so that when, otherwise if I didn't have this, if I didn't clear my screen every time for every frame, right? When I were to move this thing here, when it get previously drawn, all the colors would be previously drawn would be still there. So you may have seen this before. When the computer locks up or something like that, you end up getting this color banding, if you will. Color, when you move your thing around, it looks like it's making many copies of the same thing all over the screen until it just becomes a big color mess. And that's essentially what will happen. So basically, we're every time we before we draw a frame, we make the entire frame black, and then we draw what we want on top of that blackness. Now I can make this clear color whatever I want. I can make it white, I can make it green, I can make it whatever. But black's nice because it's going to make it stand out against anything else for color. So I just like black, personally. Okay. So that's what's going on there. Alright, and then here I'll just, I don't know. Yeah, I'll just do that, whatever. Alright, so I was talking about the camera here a second ago. So if I do that there, there we go. And then that would define out, and then our box would be in here, so to speak, if you will. It's a really terrible box. I don't care. I'm just trying to knock it out. And, you know, it's defined within this range. And that's what I was talking about earlier with the range here of 0.1. Here would be your near part to our eye view. And then, you know, 200 units out from there. Back here would be, you know, that point there. And so now we actually have a defined space in 3D of, you know, for our bounds to draw something in. Okay. So, sorry, I digress. 1.0 here for alpha again, and then close parentheses, semicolon. Then we're going to get to our GL enable, and we're going to enable our depth test. If we don't do this, then we can't define how far something is back in the view inside the simulation here for 3D, and it can really mess up your drawing. If you've gone through the CG series, you've already seen that firsthand. So we do absolutely need to do a depth test in order to help prevent any problems with that. And then we can tell what kind of functionality we want for our how we handle our depth test here. In this case, we're doing GL depth func here, open parentheses GL underscore less than or equal to close parentheses semicolon. So depending on what you need to do, depends on which function you're going to use, of course, for the look that you're looking for. GL hint here, open parentheses, GL underscore perspective underscore correction underscore hint, comma, GL underscore nisus, close parentheses, semicolon. Okay, why are we hinting? Well, the reason why we're hinting here is because we're not actually doing the graphics program verbatim hardcore. Instead, we're making a suggestion to OpenGL. And in OpenGL, if it can comply, and it's going to try its darndest, its very hardest to do so. But if it's possible for it to do it, then it's going to make it draw in the nicest method possible so that we get the prettiest, best looking results. We could do it fast and ugly. We can do it, you know, all different kinds of settings here. But we're going to tell it try to do the nicest as much as possible here for drawing the display. And then we're going to do GL enable, open parentheses, GL underscore perspective underscore correction underscore hint, close parentheses, semicolon. Okay, it's perspective correction. Basically, think about that projection matrix. And so this basically we're going to take in perspective into account, and we're going to need to multiply that times our model view, our model view matrix, so that we have perspective distortion. So that way, when something comes closer to the camera, it gets larger. When it moves away from the camera, it becomes smaller. This kind of thing, which you're not going to get from an orthographic view. So orthographic meaning no perspective distortion at all, which we can do, and we'll do later on. All right. Very cool. And then close curly brace here. And all right. The next function is going to take some time to talk about. So let's break that off into a separate video. And thankfully this code is not that long. It's only 216 lines of code. But regardless, going over this is important, and we'll need to break this up. And then after we get past some of the OpenGL stuff here, then we can get into how to draw to the screen. Then we'll get into more of the SDL, and pretty much the rest of this is SDL for the most part, going on further. So we only have a little bit more OpenGL to talk about, and then we pretty much get into nothing but SDL for the most part. Alright, so with that, in the next video we'll go over how to do draw the cube on the screen and how those mathematics work and what's involved for that. Alright, thank you very much. This has been OpenGL and SDL game development. My name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.